Before we get into learning how to subtract integers, let's review some of our integer poetry to live by. Can we put them all in order, plot the points, and we just might, because the number that is greater is the number to the right. Opposites are easy, just switch the sign or go the same distance on the other side of Mr. Numberline. An absolute value is happy, it feels like a hero, because it's the positive distance of the number from 0. If the signs are the same, then that's simply divine. Add the absolute values and keep the sign. If the sides are different, you need to take charge. Do big minus small and keep the sign of the large. When you do big minus small, you might want to make sure that you add in that you're going to be doing the absolute value of those. So you'll still have to do technically, like I said, big minus small, the absolute values of those, and then you take the sign of whatever number is larger. So now we're going to get into some subtracting of integers. So here are some example problems. The answers are given for you, and these are all problems that you should know how to do. So looking at A, we can see that we've got 9 minus 5 equals 4, which is the same thing as saying 9 plus negative 5. We can then see that 13 minus 8 is the same thing as saying 13 plus a negative 8. Moving on, and that continues in that same pattern all the way through those example problems, we can now figure out how we're going to subtract integers. So by showing that the answers to each of these pairs of problems are the same, you showed that when subtracting a positive number, subtracting an integer is the same as adding the opposite of that integer. So by showing that the answers to each pair of problems was the same, you showed that when subtracting a positive integer, you can just subtract the integer by adding the opposite of that integer. So for example, subtracting 5, the opposite of 5 is negative 5. So subtracting 5 is the same as adding the opposite of 5, which is negative 5. So now let's look at subtracting a negative number. We will use Mr. Numberline to help us with our reasoning. We're going to solve this problem. 5 minus a negative 3. Well, 5 is going to be our starting point no matter what. If we were subtracting 3, we would need to go 3 units to the left because subtracting means getting smaller and smaller is to the left. However, since we are subtracting the opposite of 3, we're subtracting negative 3, we actually need to go to the right. So one way I like to think of it is for each one of these signs, you want to switch your direction. So the minus sign means go to the left, but then the second negative sign means, oops, I need to switch my direction now, and we're actually going to go to the right instead. So if that's true, 5 minus a negative 3 really gets us up to 8. So now we know that 5 minus negative 3 is 8. Since 5 minus negative 3 is 8, and since 5 plus 3 also equals 8, this example shows that when we subtract a negative number, subtracting an integer is the same thing as adding its opposite. So believe it or not, we actually don't want to subtract. So let's talk about how we are going to do subtraction if those kind of problems come up. It says we have now shown through our warm-up and examples and by using Mr. Numberline that when subtracting a positive number or a negative number, subtracting an integer is the same thing as adding the opposite of that integer. Adding the opposite of that integer. So now we're going to write our subtraction poetry. It goes, if the problem is subtraction, then you know your mission. Just change the problem to addition. You've looked forward to this since integers beckoned. Change the minus to a plus and the sign of the second. the second number. In other words, changing the sign of the second number is the same thing as finding the opposite of that second integer that you're subtracting. So how do we, in fact, subtract integers? We don't. We actually don't want to ever subtract integers. We want to change the problem to an addition problem. And then all we have to do is add and follow our addition rules for integers. So let's look at these two examples and then we're going to try some on our own. Okay, so example number 1 is -9 minus a +5. Again, we want to change the problem to addition. So we want to do -9 plus, and then we need to change the sign of the second number. Now this is a minus sign. This 5 is actually positive. So the opposite of +5 is -5. So we actually want to add -9 plus -5, which gets us to -14. If you think about it on Mr. Numberline, if we're starting at -9 and we're subtracting tells us to go to the left, but then when we change the sign, that's why we went farther to the left. Example number 2 is -4 minus a -7, and we want to change it to addition, so -4 plus, and then change the sign of the second. That's going to become a +7. So now we need to follow our addition rules. And our addition rules state that when the signs are not the same, when the signs are different, you want to subtract the absolute value and keep the sign of the larger number. So the absolute value of -4 is 4, so we're going to want to do 7 minus 4, which equals 3. And then of the -4 and the +7, 7 is larger, so that 3 is going to stay positive. Again, when you think about it on Mr. Numberline, if I was located at -4, the subtracting is telling me to go left, but then this other negative sign is telling me to go back right, which is exactly what I ended up doing in my answer. I want you to take a second and pause the video, and I want you to take a second, don't solve them yet. Take a second and change all the problems to addition and then hit play again. So take a second and check those new equations. We changed all the subtraction signs to addition signs, and then we changed the sign of the second number to its opposite. Now go ahead and pause it and solve for all of these problems. See how you did there? So remember, always, 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 you want to change any subtraction equation to addition expressions in order to ensure that you get the correct answers. And then the only rules we really have to memorize are going to be for addition. We don't have to really think about subtraction rules if we're going to change it to addition every time. As we move on, there will be other rules to memorize, but for this purpose, let's make sure that we always change a subtraction problem to addition, and then we change the sign and find the opposite of the second integer.